Hi there, my name is Miss Townsend and I love math. Welcome to Math with Townsend. This video is for students in MCF 3M who are working towards their summative. It's question number 3 from the series of practice questions. Here's the question. The function, blah blah blah, gives the height in meters of a golf ball being hit on the moon. So we have a function and it represents the height in meters of a golf ball. So it doesn't say it, which I think is probably an issue. We'll have to fix that. But I'm guessing t is time, and I'm going to guess it's in seconds because, well, golf balls, even on the moon, aren't staying up there for hours. I think someone asked Dr. deGrasse Tyson. So this is the equation that represents the height of a ball over time. Now, once you've established that you understand the information you have, now I'm going to look at algebraically what I was given. I was given a quadratic, so that squared would mean that if I were to square this bracket, I would see t squared and nothing more complicated. So I know it's quadratic, plus I recognize it as vertex form. So I've been given a quadratic in vertex form, and then there's some questions I have to answer. So now that I know it's a quadratic in vertex form, let's look carefully at the questions we're supposed to answer. What is the height of the ball when it is hit? So obviously this is a question telling me to find height. So I need to find the h at t value. And that means I must know that t equals something. So when it is hit, what time is it? Well, this formula only starts occurring when the ball is hit. So the ball is hit when at time equals 0, because that's the moment the ball starts flying in the air, which is the moment that this equation starts to measure the height. So this question is saying, let t equal 0 and solve for height. So it's an algebra, purely just straight up algebra, sub 0 in here, and then follow order of operations to get your height. Okay, I know how to do that one. So let's look at the next, and I've grouped these two together because they're obviously related. What is the maximum height reached by the golf ball, and what time does the ball reach maximum height? So both of these are asking me about the maximum of this quadratic. So as soon as you see the word maximum, or sometimes minimum in a quadratic, you know that what you need to do is find the vertex of the equation. The vertex, which is x comma y, well, in this case I don't have x, so the vertex will be t comma height. So if I can find the vertex, I'll know both the height and the time for that maximum. And of course, this equation is written in vertex form. So I have virtually no math to do, because when it's given to you in vertex form, the vertex is staring you in the face. You'll recall that vertex form, when you initially learned it before any numbers were introduced, looked like this. And then the vertex was always h comma k. And the most important thing to remember is that the reason why the vertex form we write x minus h and not x plus h is because the h value that you see, so I see t minus 25, but my vertex will have positive 25. Because it's the opposite sign to what you see. And again, logically, it's because it's actually the t value that makes this 0. So it's 25, subtract 25 makes that 0, which is why we don't take negative 25, we take positive 25. So I'm going to just need to look here and find my vertex to answer both B and C. And then part D says, how long is the golf ball in the air before it hits ground level? So how long is it in the air? So that is a question about time. I need to find time. And I need to find time when the height is what? So if I'm looking for time, I must know height. So ground level is a height. Ground level is where height is 0, because it's at ground level. So if the ball goes up in the air and then it comes back down, I'm looking for how long it takes to get to that 0 point, which is ground level. So that means I need to let height equal 0 and solve for t. So in this equation, I'm going to substitute 0 in for height, and then isolate the t value by doing careful algebra. And once I've isolated t value, I'll be able to tell you what time it takes to get that height of 0. So I've now talked you through how you can get the answers to these questions. So what you have to think about, what algebraic tools to use. So I suggest at this point, if you haven't already done so, pause the video and actually do the math right now. So get out your pencil, your paper, your calculator, and try these questions now that you've been given some suggestions on how to do the math. Make sure you can now actually do the math. Don't just watch me do it, make sure you can do it. And then when you're done, start the video again and we'll take it up. So, again, we have this vertex form quadratic, and it says, what is the height of the ball when it is hit? So when it is hit is when time is 0. That's what time the ball is hit at. And so I need to find h when t is 0. So h at 0 is, so all I'm going to do is substitute 0 for t, and then just do the algebra, remembering order of operations. Oops. So according to order of operations, I have a bracket, and inside that bracket there's math that I can do. 0 minus 25 is negative 25. Now, following order of operations, what do I have now? This is multiply. Oh, there's an exponent, so now I have to do the exponent. So negative 25 squared is positive 625. Then negative 0.8 times 6.28 comes before the plus. So negative 0.8 times 6.28. So when I multiply this, I get negative 500. And then finally, I can do negative 500 plus 500. Oh, the height is 0. So the height of the ball, when it was hit, is 0. Which means the ball was actually hit directly from ground level. It wasn't on a hill or a cliff or something. So we have to be able to calculate that. And again, one of the most important things here is that you have to know that when this formula represents time and height, the moment that it's hit is the moment that this formula exists. And so the moment it hits is the start of everything, which is when t equals 0. And by subbing it in and follow order of operations, I calculated the height. So now I'm going to find the maximum height reached by the golf ball and the time it takes to reach there. And again, because it's in vertex form, I'm just going to look and find where the vertex is. So in this case, it's at positive 25, 500, because it's in vertex form. So the vertex is this number, but change the sign, and this number, leave the sign alone. So positive 25, 500. And again, that's t and h. So the maximum height is the height in the vertex, which is 500 meters. And the maximum height is reached at time, 25 seconds. So that's what we like the best about vertex form, is how quickly you can answer questions about the vertex, meaning about maximums. And then finally, we have part D. How long is the golf ball in the air before it hits ground level? So again, how long is it in the air is asking me to find t. And ground level, well, ground level is when the height is 0. So I'm going to now make the height 0 and solve for t. So I'm going to have to do some careful algebra here to solve for t, because I'm not just doing order of operations, I'm isolating a variable, which means I need to take everything that's happening to this t variable and make sure that it's on the other side. And in this case, I have to reverse my order of operations. So again, I'm just going to talk you through it in case you find this problematic, because it's a pretty big algebra exercise. So the t is in a bracket with minus 25. So minus 25 is the closest thing to t and the last thing I can do, because I can't get to t until I get to this, but I'm not even in the bracket yet. I always, when I teach this, I talk about the t is the king, and I'm trying to attack the king, but I have to get through his bodyguards. So this is his close bodyguard, and then they're both protected by this bracket squared, and that bracket squared would be protected by this, and this is the first thing I can do. I can get rid of plus 500, and again, you'll notice I'm just reversing the bedmess order of operations. So how do you get rid of add 500? Well, you subtract 500. So the first thing I do is subtract 500 from both sides, because now I have that bodyguard is missing. Now I need to get rid of the multiply. So if I multiply by negative 0.8, the way to get rid of that is to divide by negative 0.8. And I have to do it on both sides. Divide both sides by negative 0.8. So 500 divided by 0.8. I didn't say negative 500 divided by negative 0.8 because we know that a negative divided by negative is a positive, so why type that into my calculator? So that gives me 625 equals, and then this is gone. So now I have just the bracket thing squared. So now I have to get rid of squared. He's a tricky bodyguard. Be careful. The opposite of squaring something is to square root it. But remember, when you are taking the square root, you should get two answers, the positive and the negative. So the square root of 625 is 25. So both positive and negative 25. So that means I actually want to split my answer into two different maths now. Positive 25 and negative 25. So you'll notice the right side of the bracket, that can't change. That's just t minus 25. But on the left, I have both positive 25 and negative 25. So now I only have to add 25 to both sides. So I get 50 and I get 0. So what that means is that the height of 0 right here along this line, there's two times that the rocket's at a height of 0. Once is at time 0 and once is at time 50. So the rocket does this, well, symmetrically and nicely, whatever. So when it says, how long is it in the air before it hits the ground? Is it in the air for 0 seconds? Well, no, that's where it started, which means it's in the air for 50 seconds. So my answer is 50 seconds. Now, I want to point out to you that in this particular question, we could have got our answer a slightly different and faster way. It doesn't always work. It just happens that in this question, if we go back to part A, we knew that this golf ball started when t equals 0. It started at 0 meters. And we knew that this was the vertex at 25,500. So if we sort of build a picture of what's happening, it starts at 0. It goes all the way to the maximum, which is 500 meters, and it takes 25 seconds. Now, because it started at 0, when I want to get it back to 0, I'm going to use the symmetry principle, which is that every parabola is symmetrical around the line of axis. So because it was 25 seconds to go from 0 to the maximum, it must be 25 seconds to come back down. So if this is 25 seconds and this is 25 seconds, it's 50 seconds. Now, be careful with this little shortcut, because if the starting height was not 0, you can't use this shortcut to answer this sort of question. You have to do the full math like I did here. So when in doubt, always do the full math. But if you remember, if you do happen to start at a height of 0, you can use the symmetry principle to answer some questions a little faster. Anyway, I hope that was helpful. Again, think about the key ideas that we just discussed. What's important about the vertex form? How do you use the vertex form? Well, the easiest thing to do is to find the vertex, meaning the maximum stuff. But you also need to be able to substitute values in for t and calculate height. And you need to substitute values in for height and calculate t. So I hope that was helpful, and happy studying.